welcome everybody to use case number 4, that is Wagering on Esports, how game data becomes betting odds, and is presented by Darina Goldin. Before starting, just few technical details. So the session will be recorded and can be posted also on YouTube. So maybe the chat will be visible. If you are not okay to show your name and comments, just don't write them. But otherwise, please use a lot the chats to share your comments and questions. Indeed, at the end, we will have around 10 minutes of Q&A. So we are going to answer your questions. So write them so you don't forget. And so I am Elena Bonan. I will be your moderator for this session. I'm a data scientist at King, which is the company of Candy Crush, the game. And yeah, I'm super excited to hear the presentation of Darina. Indeed, esports is a new and exciting industry where there is really a lot of data and challenges. So I'm sure that today we can really learn a lot from Darina, who has a lot of experience and knowledge in bets and esports. So thank you a lot, Darina, for presenting today. And yeah, now I let you start your presentation.
Thank you very much, Elena, for the introduction. I personally love Candy Crush. Today we're going to talk about video games, but a different kind, the kind where you actually compete against each other. So judging from experience, half of you are here because you're either super into esports or super into sports betting, or maybe both. And the other half are here because you've never before even were aware these topics exist, and now you're interested to hear what it's all about. And hopefully I can cater to both audiences a bit here. So I'm going to quickly introduce our company, and then also esports and esports betting. And then I will focus on the use case for this presentation, which is machine learning for betting odds and the pipeline that then puts them in production. So why am I qualified to talk about this? Well, mainly because in grad school, I played Team Fortress 2. And I did this very, very seriously. So it was 20 hours per week of training, plus matches on the weekend. It was basically like a competitive sport. And then when I had a chance to get into an esports job after my PhD, I just took it. And I've been in the industry ever since, and I'm not planning on leaving. I think it's really exciting. There's a lot going on and a lot to learn and to discover still. And then in 2016, we had our first betting project for a customer. And I was in the team from the beginning. I ended up leading it for a while then. And currently, I'm one step above that. So I'm director of data science, means that I supervise both the betting data scientists, but also all the other data science and research in the company. And if you care, I have a PhD in control science, which is basically just data science before there was data. Why esports? Because esports, at least pre-corona, looks like this. So you have a full stadium. We have lots of fans. We have exciting events, competitions. We have professional athletes who live from this. We have media. We have news, gossip. We have huge productions. And of course, we also have advertising money, gambling money, prize money, all sorts of revenues coming and going there. And it's here to stay, and it's here to grow. Every year, we have more people who grew up with esports, who see them like a real traditional sport, coming into adulthood and really being able to consume it as somebody who pays money, which for us, of course, is important because we all want to kind of make money and have a good living, but also just who understand and value these games and really enjoy them. Just the way people enjoy soccer, there's more and more people who the same way enjoy League of Legends. And especially Corona, of course, gave us a huge boost because suddenly there was no sports going on. But esports can be played entirely online. And so esports matches were still happening. And I just pulled the first 4 random graphs from the internet, just to show you that they all say esports is growing and esports is an exciting market, and it's taking over most traditional sports already by now. And Bayes Esports saw this from the beginning. And from the start, we said we want to use esports data and monetize it. And we also want to grow the ecosystem, because if the entire field becomes bigger, then everybody benefits and everybody can grow. So we are very engaged there. We are a purely B2B company. So we have two main legs we stand on. One is a data exchange platform. So we have rights holders, tournament organizers who then have their game data, and they can feed their game data to our platform and sell it through us. And then on the other hand, we have media partners or betting partners or anybody who wants to consume live or historic esports data, and they can then come to us and implement our API and get the data from us, and we take care of everything else. So before we existed, basically you had to go to each tournament organizer individually, you had to implement their API, get a contract with them, get their fixtures, etc., and we take away all of that and simplify it for both sides. Our other big leg that we stand on is the betting, which is what I'm going to talk about today, where we provide esports betting odds for the big three currently and looking to extend into other matches, other titles as well. And as a side note, we're named after Sir Thomas Bayes. It's not a coincidence we're called Bayes. And this is just what happens if you let data scientists name your company. And if you have not seen esports before, or betting before, sports betting, here's a brief primer. So on the right, we have this screenshot. I hope you can see my mouse here as well. There's a live Counter-Strike game going on right now. And here on the left, we have the odds for this game. So currently it's 185 for both teams. These are so-called decimal odds, and they just tell you if you bet €1, then you get 185 back. And what we see here that it's an even game. So the probability, the true probability we call it, for each team to win is currently 50-50. It can go both ways. But if we actually compute the probability that's implied by these odds, then we just take 1 over the decimal odd and we arrive at 0.54. So there is the 0.04 that's just added on top, where the probability is inflated a bit. This is what we call the implied probability, and it's how bookmakers make money. So if you think about it, if we have the same amount of money wagered on both teams, then one side will win and one side will lose, and there will be a difference in these in the payout and what theoretically would have been paid out if the true probability would have been observed. So, for example, if you bet €1 on both sides, then you get 185 back and you lose 15 cents. This is just very briefly to explain the difference between the true and the implied probability. It's quite important for my presentation. If you want to know more about this, there is a blog post I wrote for our company blog that just gives you a gentle introduction into all these terms. And you can also just ask yourself 2 questions that I put here to check if you understood. We could also price this match at 1-7 or 2-0, and which one of these 3 would be the fairest? And the second question is, if you look at this match here, which of the 2 teams is the favorite to win? What do you think, and how do you compute that? And with this, moving on, how do we actually get to this? So how do we get from the game to probabilities and then to odds? On the very left, we have the live game data coming in, either from the server, or sometimes we just have this video stream that we then have to OCR into the actual data. Whatever happens, it's called the parser. The parser transforms the game data into something that's human-readable game states. They go into this predictor box, which I will open in the next slide. And then the predictors output the true probabilities. And then a human person looks at true probabilities and also looks at the betting market in general, competitor odds, what kind of bets are getting made. And then maybe they don't like what they see. In this case, they give a feedback using sliders where they really just can adjust what they want to see. And this goes back into the predictors in a loop, and probability get adjusted and so on until traders are happy. And then these odds are then sent to the bookmakers and can be actually bet on by customers on websites. So now you might actually wonder, why do we even need machine learning if we can just have humans, and humans still have to be there? Well, here on the top, you have a screenshot of what a trader's workplace looks like. And just for scale, here's another shot of just betting traders sitting there doing their job. So they have to watch the game and adjust and turn all these little knobs. And as you can imagine, a human can only do this many matches at a time, usually just one. And then there's not only one market, but there's different markets that I will talk about soon. And a human just can only do a limited amount of work at the same time. But if we have model-driven odds, then they no longer have to actually watch every single match. They just have to monitor And so they increase productivity, and now a human can maybe do 10 matches, 50 matches, depends on the model. Maybe you can even automate something of what the human is doing. So you really increase productivity there, but you still have the same amount of risk. And also, specifically for esports, we have a huge benefit because we have all the data available. So, for example, let's say we have table tennis, and then if you're just watching table tennis game, then you see maybe how the ball is going, maybe how many exchanges are going on, but that's already difficult to see. And if table tennis was an esport, you would know the slant of the bat, you would know how high the ball went over the net, you would know which angle it went into, and so on and so forth. And all this data, of course, lets us make much, much better models than humans could do with just statistics. What can we even bet on? Well, like in traditional sports, we have the map and the match winner, and handicap lines and outrights. And then specifically for mobile titles, we also have the objectives. So like the first kill, first tower, first Baron in LoL, first Roshan in Dota 2. And for shooters, we then also have round winners because these are based in rounds. And then objectives like bomb, plant, and defuse. And total kills, total headshots, will there be an ace in the game? All sorts of different things that are really game specific. In terms of data, in pre-match, we only have information about the teams. So who's playing, how have they played before, how they posted on Twitter, how do they look, rumors, all that goes into the pre-match models. And then live, we have a much better situation because we have the full game state and we actually really know what's going on and can apply data science very, very well here. So then to talk about the pipeline. So of course, if we want to have models, we have to do research, and this happens in Jupyter Notebooks. So we have aggregated historical data that then data scientists then use for feature selection and training, and of course also evaluation of models. Evaluation of betting models is a topic for itself because it's quite specific to the industry. And then the trained models get implemented in Python backend. So there are pre-match predictors, like I said before, and then we have the live predictors that accept the game state. So the live predictors, look into them a bit more. We have here the model again, and the feature generation is also implemented in Python. And then it gets the pre-match prediction and the live game state, and there's feedback from the traders as well. All that is then goes into the model, and the prediction, so the probability of one team or the other team winning comes out. And then it goes to the traders who give feedback and so on. So we have this loop here. And ultimately, this is the heart of the betting system. So yes, I think this was exactly 15 minutes. I'm really looking forward to questions. I hope I was able to give you a very brief overview of this, and then we'll see what you think interesting, and we'll talk about that in the next 15 minutes.
Thank you, Darina, for the great presentation. Yes, please write in the chat every doubts you have, every curiosity. And otherwise, I can start, that I have a curiosity. I would like to know which was the greatest challenge you had encountered when you were doing the modeling part. Like for this specific task, which is the greatest challenge in the modeling part?
So the greatest challenge first that we had in the beginning was understanding betting at all, because it's quite different when you come from machine learning. You have things like mean absolute error and all these evaluation methods that you learn, and they don't apply because the trader will come to you and will say to you, yes, maybe this is the correct prediction, but nobody will bet on it. For betting, we need it to be like this. And so just understanding the market and understanding what people actually want, and learning that, for example, odds cannot jump randomly. So we can have a very, very good model, but the model jumps even though the feature is continuous, and then we can't have it. We can't use it. And all this took years of back and forth. And I think by now we really understand what we need to do. And we have a massive book. So if you start as a data scientist in betting at Bayes Esports, you have to more or less read a book about betting odds. And the other challenge that's very specific, so I think this is a little bit true for any sport, but one challenge specifically to esports is we have patches. So if you know esports at all, you know game developers like to keep things interesting. They like to, sometimes every couple of weeks, sometimes several times per year, change things around. They will balance some heroes. They will add new buildings. They will remove buildings. And this changes the game. And with this, we have to get new models. And sometimes we have to get them very, very fast because the game just changes a lot. So it's always been a challenge.
Okay. Okay, I see that we have a question that asks specific, which metric are you then using to optimize the models?
Well, first of all, we can never just look at averages. We always have to pick out specific games which are outliers and look at those. So we have to keep track of these matches. And this is because, for example, if you do shopping, then if 90% of your customers are happy, then you're happy. You're making a lot of money. And the other 10%, well, you're losing some, but it's fine. Whereas for us, if we have one match where we really fail and we have really bad odds, then the so-called smart money, the people who actually make money from betting, they will come like vultures and they will kill your entire month's profit. So we can't afford having that at all. So we have, before my models even go on production, we have these standardized test cases. Then we also look at like odds behavior over time, because, for example, at the beginning of the match, you don't know who's going to win, period. It's always 50-50 based on the game state, right? Because just teams are even. And so we have to really make sure that the odds start at 50-50 and then over time they go to the favorite, things like that. And then, of course, there is also the post-game metric. So once the match has happened, we know who bet on and what they bet on. And of course, there's a confirmation bias. So people will bet on certain odds and they will ignore other odds. But then we will always look into where did we make money, where did we lose money, and why did that happen? And yes, so that's a lot of our evaluation as well.
Okay, great. Michael, if you answer the question, or if you have other doubts, you can write in the chat. Otherwise, I have also another question regarding the prediction. I mean, in some other industry, you can train your model like daily or after some weeks and so on. But here it seems you have also to do like live prediction. So I would like to know which are the greatest challenge in this for this task, and if you had to adapt some tricks to make it work very rapidly, the prediction and so on.
So we can still train daily and just deploy. I mean, we have pretty good DevOps that ensures that nothing breaks in the meantime. And we are, for us, the challenge is more that after the training, we have to always check the model again versus the standards. And so we have actually our own internal model training framework, well, that is automated, and then a person approves it, and then it can go into production. We actually have to train daily or as often as possible because of these patches. So we always have to use the most recent data to be sure our model is still fine. And especially after a patch, we definitely need to look into the patch notes and see, and just have an estimate, is it going to perform, and then actually test as the games come in with new games.
Okay.
Does that answer the question?
Yeah, thank you. And yeah, and also, okay, I'm curious also to know how you, when you like deploy your odds, you also have to look at what is the market, what are the other companies doing, and so I would like how you take this in consideration when there is the trading algorithm at the end.
Okay, so this is a huge topic because now we're going into the risk mitigation and betting, and there are different paradigms depending on where in the world you even are, who your customers are. In our case, we mostly data, and who is a big odds reseller, and they would like to follow the market. So what this means is they don't want to be the one who sets the trend in odds. They want to be in the center because they have their customers who want to be safe. And the problem is if you have odds that are different from everybody else, then you open yourself to arbitrage. So people will bet with you, and they will bet with somebody else in such a way that they are guaranteed to make money. Basically, like this example I had of the bookmaker making a profit, by inflating probabilities. The same thing the punter can do if they find the right odds, and it's not that difficult. There is software available for that. So this is why we look at the market, how it moves, and then try to stay within the bounds.
Okay, yeah, it makes sense. Wow, I think it sounds like a lot of things to control.
Yes, risk management and betting is a very exciting and complicated topic. But it's really related to financial industry, actually, where you look at the trades as well.
Oh, okay. So we have another question from Michael. And he asks how you take into consideration the skill difference between teams and players.
Well, there are two things here to consider. One is we have models for team skill. So the very common model that we also use is Glico2, which is developed by Mark Glickman. There's also ELO in chess, maybe you've heard of that, and there's TrueSkill. So they're just Bayesian models where you have an estimation of a true skill of the team, and then some variance, and then from that you can compute the pre-match probability. And that's based on results. So that's based on match results, past history, and then the more recent ones are weighted a bit more, so you can have this skill degradation kind of. For esports, because they don't switch teams a lot, they usually stay together. So it's fine to just take the team skill and not individual player skill for us. And this is the long-term estimation. And then before the match starts, so even a couple of days before, as soon as pre-match odds are available, basically, people will bet on it. And that gives us also feedback. So if our odds are off, then people will go and put money. And so we know, oh, we have to adjust this. And also there's the smart money where we know somebody is good at knowing information. And so we know if they're betting on this, then they probably think this person is going to win. And so we have to follow them, their knowledge as well, a little bit.
Okay. I think it answered the question. Michael, otherwise, write some comments. Yeah.
Great. Again, team skill estimation is open research topic. It's super interesting as a data scientist to get into that as well. I can really recommend it. It's one of my hobbies.
Now I'm curious, since there are a lot of challenges, is your team divided and specialized in some area, or everybody follow all the pipeline of the models?
So everybody knows how to train models, and everybody understands the backend because it's very important to have a redundancy. We're not a big company. We're the total company, including all the branches, are I think currently 50 people. So we're not Zalando. And then we have some specialty knowledge, of course, as well. So, for example, I'm really into these pre-match predictions, and then we have experts for the titles. For example, we have a League of Legends expert, we have a Dota expert who really understand those. We have trading experts. Yes, and we have quite rigid guidelines in terms of how you need to so the betting. I'd say we've solved it. We know how to do it, and we have guidelines how to do it.
Oh, that's amazing.
Besides who win the match, what other predictions do you make, and how does this approach differ from match winner? Well, like I said, we do objectives for MOBA titles. Usually we do the first objective because that's the most interesting for the punters. In general, these side markets people don't bet on them as much as they do on match winner. So how does the approach differ? Well, first of all, your data set is usually smaller because let's say a match takes 30 minutes and then the prediction is, and then the first objective falls maybe in the first 10 minutes, or if it's first blood, then it's a couple of minutes later. And then it doesn't really differ that much, really. They are more volatile. So they are more subject to patches, for example. Like in Dota 2, we had the first shrine mark. So yes, so in Dota 2, there was an update, and they introduced Shrine, which is a new building. And we were like, yay, let's make a new market. So we made a first Shrine market, and it was cool. And then at some point, they moved the shrines, and then at some point, they moved them again and changed their value. And then the shrines were removed again completely from the game. So we really have to monitor side markets more. And then we also have some constraints, like the side markets, or certain side markets are very indicative of the match winner as well. For example, in LoL, if you take an inhibitor, you're probably going to win the match. So at the beginning of the match, we cannot predict the team A to get the inhibitor and team B to win the match. Like, that wouldn't work. So these predictions are always taken, these constraints are also taken into account programmatically. Do you retrain models frequently, or how do you solve if the rules of the game change? Yes, we retrain. Yes, exactly. We retrain frequently. We keep track of patches. We prepare. Like sometimes for Dota 2, you can foresee there's going to be a patch because there's always been a patch before TI at some point. So we can prepare for this mentally, and then we just retrain. And we also have some know-how by now. What kind of models to use to make them more robust against patches as well. So we're not hit by them as hard as we were in the first year we were doing this. But it's always a challenge. And I think this is the biggest challenge in esports overall, is dealing with patches. And maybe one day we will have some kind of self-play where we can just generate matches after a patch. I would love to see that at some point.
All right. And yeah, we have a few minutes left. So if you have some other question, please post. That is the last occasion for this session. But otherwise, Darina will be available later if you wanted to write to her here using the platform or with the email that she shared, and follow her on Twitter.
Thank you. Thank you, Michael, for all your questions. I really appreciate it. Fire on.
Yeah. And and okay, last question. And how is difficult to adapt everything for the different games you have? I mean, every time there is a new game, can you share how much of the tech you have to change and so on? And
for a new game, this is something we are considering right now. We are actually developing a fourth title. So the entire backend is that works. That's just plug and play. It doesn't matter what title it is. The more difficult part is understanding the game and understanding the kind of models you need to use. So for example, a new MOBA title, that would be quite straightforward. We would just need to get the historical data, and then it would be business as usual. And then if it's something esoteric, like for example PUBG, which is a kind of a last player takes wins kind of situation, that's radically different. And there you have to really think about the game a lot, and the modeling just takes a lot of time. And so before I used to say, yes, we need this amount of time for a title. And now I would not say that anymore, because it really depends on the title. And there are titles we could just do within a month or so if there was interest for them.
Okay, thank you. I think, unfortunately now time is over. So thank you a lot again for the presentation and so on. And now we will move to the network and export part. And hope you had a great time here in the session. Yes. Thank you a lot for joining.
Thank you very much, Elena, for the moderation. And thanks for the questions.